Today we will look at the second lesson in Unit 6.2 solving equations by using balanced strategies. This topic also can be called solving equations with variables on both sides. Since this is a long lesson, I decided to chunk the whole lesson into two small parts again. So today we will focus on the first part on how to solve equations by using balanced strategies. From the first way of talking about the topic, we will know the method we will be using to solve the equations. From the second way of talking about the topic, we will know what features those equations contain. So today, we will learn how to solve the equations with variables on both sides by using the balanced strategy. The balanced strategy is a very good method to isolate the variables from the constants. This method, or we can say this strategy, usually is modeled by the balanced scales. The scales remain balanced when we do the same thing to each side. Okay, if you still have trouble in understanding this one, we will understand this concept by solving the first example. Let's look at the first example. Use balanced strategies to solve 6x plus 2 equals 4x plus 10, and then verify the solution. Let's look at this equation first. In this equation, we will find I have the variable x on the left side. I also have the variable x on the right side. In this equation, I can see the variables on both sides. So let's solve the equation by pictorial solution first. Then we will convert this pictorial solution to the algebraic solution. Let's draw the equation for the left side and the right side on a balanced scale. 6x plus 2, this is the left side, which means I draw 6 blue X boxes. Of course, you also can use the yellow rods to represent 6x. I will use the green ball to represent 1. So 6x plus 2 means I have 6 blue boxes on the left side, 2 green balls on the left side as well. The right side is 4x plus 10. That means I have 4 blue X boxes and the 10 green balls representing 10. If I want to solve what is the value for 1x, that means my goal is to leave 1 blue box at the end. I found that I can remove 4 blue boxes from each side, which means I need to remove 4x from each side. So those ones got disappeared. This time I only have 2 blue boxes, which represents 2x's left on the left side, and the 2 green balls on the left side, and the 10 green balls on the right side. Then I find that this one only has 2 green balls. This one has 10 green balls. I remove 2 green balls from each side. So these 2 green balls on each side got disappeared. After these 2 green balls got removed, I only have 2 blue X's left on the left side. Then 8 green balls left on the right side. Divide the methods in each pen into 2 groups. This is my goal. I need to find how many green balls represent 1 blue X box. So I divide 2 blue boxes into 2 groups, 1 box in each side, in each part. And I also divide these 8 green balls into 2 groups. I will find 4 green balls in each group. So that means 1 blue box corresponds 4 green balls. So I can get X value is 4. So this is the pictorial solution. How can we solve this one algebraically? Let's write down the original equation again. follow all the steps in the pictorial solution. I only need to convert the information to the algebraic steps. The first step is I remove 4 blue boxes from each side. So I take away 4x from each side. On the left side, 6x minus 4x. You can combine the like terms. You only have 2x left. Then plus 2. On the right side, we have 1 4x, 1 negative 4x. These two terms got cancelled out. So that means on the right side, I only have positive 10 left. Right now, you will see this equation becomes a very familiar equation that we learned in 6.1. I can use the inverse operations to find the x value. I have plus 2 on the left side. So I need to subtract 2 from both sides. Cancel these two terms. 2x equals 8. Then 2 times x equals 8. The inverse operation should be dividing. I divide both sides by 2. So x equals 4. Let's verify this solution to look at if this solution can fit the equation. Let's substitute this value 4 for x on the left side. I use LS to represent the left side. So the left side becomes 6 times x. X right now is 4 plus 2. So 6 times 4, 24 plus 2, 26. Right now, let's look at the right side. The right side is 4x plus 10. So right now, the x value is 4. I replace the x with 4. So 4 times 4 plus 10. Let's look at 4 times 4, 16 plus 10, which is 26. This one means the left side equals the right side when x equals 4. So x equals 4 is the correct solution for the equation. So that's how I can use the algebraic method to solve one equation with variables on both sides. Okay, let's try to solve this equation using the algebraic method we just finished in example 1. Let's look at this equation is negative 3c plus 7 equals 2c minus 8. Need to realize my goal here is to isolate the variables from all the constant terms. That means I want to put the c term on the left side and all the numbers on the right side. So I want to get rid of 2c from the right side. You also can think about the inverse operation for 2c as well. So 2c, this is a positive 2c. If I want to get rid of this 2c, that means I need to subtract 2c from both sides. Negative 3c minus 2c, combine the like terms. This one is negative 5c. Then plus 7 equals negative 8. Then I want to cancel this positive 7 or plus 7. So what I need to do is I add a negative 7 to both sides, but you also can say subtract 7 from both sides. So I subtract 7 from both sides. Positive 7, negative 7, they got cancelled out. So I only have negative 5c equals negative 8 minus 7. This one is negative 15. Then I divide both sides by the coefficient of the variable c. Negative 5 times c. The inverse operation is dividing both sides by negative 5. So 1c equals positive 3. You can verify the solution by replacing the c value with 3 on both of the sides to look at if the left side is equal to the right side. If the left side is equal to the right side with c equals 3, this one means c equals 3 is the correct solution for this equation. I want you guys to pause the video here for a little bit of while and solve those 4 equations yourself. Then come back to the video to check the answers with my answer. The first one, I want to remove negative 30a from the right side. So I add a 30a to both sides. Negative 6a plus 30a, combine the like terms. That's 24a equals negative 30a plus 38 on the right side. They got canceled out. I only have 30 left. 24a equals 30. If I want to solve for a, I divide both sides by 24. So I will get a equals 30 over 24. Let's reduce the fraction to the lowest term by dividing the top and the bottom by 6. So it's 5 over 4. Of course, you also can use the calculator to help you find the answer in decimal form. Let's look at the second one. I want to remove 2.8c on the right side. This is a positive 2.8c. How can I remove it? I subtract 2.8c from both sides. Negative 1.2c minus 2.8c. They are like terms. Let's combine the like terms. So this one becomes negative 4c. Plus 5. 2.8c, negative 2.8c, they got canceled out. On the other side, I only have negative 8 left. Then I want to isolate positive 5 from negative 4c. I subtract 5 from both sides. Positive 5, negative 5, they got canceled out. Negative 4c equals negative 8 minus 5. It's negative 13. Negative 4 times c. The inverse operation is dividing. Divide both sides by negative 4. Therefore, the c value is 13 over 4. You also can see the c value is 3 and 1/4. Or you can just write down 3.25 in the decimal form. Let's look at the c. AW minus 12.8 equals 6W. I want to remove 6W from the right side. So I do inverse operation. Positive 6W, I subtract 6W, or add negative 6W to both sides. These two got canceled out. That means on the right side, I have 0 left. Combine the like terms on the left side. AW minus 6W, it's 2W, minus 12.8. Isolate negative 12.8 from 2W. I add 12.8 to both sides. In order to cancel, one positive, one negative. Then I have 2W equals 0 plus 12.8. It's 12.8. This one is the multiplication. If I want to find a W, take the inverse, which is dividing. So divide both sides by 2. So W equals 6.4. Use the same way to solve the last one. First, I want to remove negative 5.7x from the right side. If I want to cancel this one out, I need to take the inverse operation. Add 5.7x to both sides. Negative 2.5 plus 5.7x. Let's combine the like terms. So this one is 3.2x minus 2. And these two got canceled out on the right side. So the right side, you only have 6 left. Then I want to isolate negative 2 from 3.2x. I need to add 2 to both sides. These two got canceled out. 3.2x equals 8. I divide both sides by 3.2. So x equals 8 divided by 3.2. You can use the calculator to help you find an answer, which is 2.5. So x equals 2.5. You can verify the solution in each equation by replacing the variable with the solution I found to check whether the left side is equal to the right side. Right now, we need to look at the second subtopic. We need to look at how we can solve the linear equations with rational coefficients, which means I will have the fractions as the coefficients in the equations. What can we do to get rid of the denominators for those fractions? Okay, let's look at the method here. We need to create an equivalent equation by removing the fraction, which means the denominator first. Then solve each equation and verify the solution. Let's look at the first one. The first one is, this one is not a rational coefficient, but this one has the variable r in the denominator. The principle will be the same as rational coefficients. If I want to solve for r here, this r is in the denominator right now. I want to remove the r from the denominator. If I want to remove this r from the denominator, I will multiply both sides by r. r divided by r, they got canceled out because r divided by r is 1. So 122 equals 3 times r. This equation is the same as 3 times r equals 122. Then I divide both sides by 3. So r equals 122 divided by 3. Of course, you can convert this answer to the mixed number or a decimal. Let's verify the solution to look at if 122 over 3 is the correct solution for this equation. Let's look at the left side. The left side is 122 divided by r. This time, I need to substitute this r value for this r variable. It's 122 over 3. 122 divided by this one, I can change it to multiplication and flip the bottom fraction, which is 122. Okay, this top is 3. So this one, I change this one to 122 over 1. So then I will have 122 over 1 times 3 over 122. You guys can use the cross out. And both of these two numbers are the same. One is on the top, one is on the bottom. I can cross them out. It's 3 over 1. And this 3 is exactly the same as the right side. So that means my solution, 122 over 3, is correct. The second example, with the authentic rational coefficients on both sides. Let's look at this equation. 2a divided by 3 equals 4a divided by 5 plus 7. We will see 3 in the denominator on the left side, 5 in the denominator on the right side. What can we do with these two denominators? We need to remove these two denominators, of course, first. How can we remove these two denominators at the same time? Here is one suggestion. We remove the denominators by multiplying each side of the equation by the lowest common denominator. Let's look at what is the lowest common denominator for 3 and 5. That's 15. So I will multiply both sides of this equation by 15. And I want you guys pay attention to the right side. When I multiply this addition by 15, put a pair of brackets to show this is one family first. So right now, let's look at the left side. 15 times 2a over 3. 15 and 3. One is on the top, one is at the bottom. You can do dividing. 15 divided by 3. Or you can say cross out. 15 and 3 was 3. So this one is 1. This one is 5. So 5 times 2a is 10a. Equals. The right side has a pair of brackets. You can use the distributive property to remove the brackets first. I will have 4a divided by 5 times 15 plus 7 times 15. For this 5 and 15, I will reduce the fraction to the lowest term. Make this one 1, make this one 3. 3 times 4a is 12a. And keep the left side, 10a. Then plus 7 times 15 is 105. Then I will see that I change this equation with the rational coefficients to the equation with integral coefficients, but with the variables on both sides. We know how to solve the equation with variables on both sides already. So I will subtract 12a from both sides in order to remove 12a from the right side. So then 10a minus 12a, combine the like terms, it's negative 2a equals 105. Then divide both sides by negative 2. So the a value is negative 52.5. Let's verify this solution. So on the left side, I will replace the a with this negative 52.5 value. So it's 2 times negative 52.5 divided by 3. You can use the calculator to help you to get to the result on the left side, which is negative 35. On the right side, I will do the same thing. So I replace the a value with negative 52.5. So I will have 4 times negative 52.5 divided by 5, then plus 7. If you use the calculator, you will find, okay, this result is also negative 35. The left side is equal to the right side. This one demonstrates negative 52.5 is the correct solution for the equation. So right now, I hope that you guys can have a try to use the lowest common denominator and multiplying both sides by the lowest common denominator to get rid of the denominators and solve the equation yourself. So we will see 4 and 6, the lowest common denominator. For both of these two denominators, 12. So I will multiply both sides by 12. On the left side, let's remove the brackets by using the distributive property. So it will be 12 times x over 4 plus 12 times 7 over 4. On the right side, you can simplify this right side already. 12 divided by 6 is 2. 2 times 5 is 10. Let's simplify the left side. 12 and 4. 12 divided by 4 is 3. Make this one 1, make this one 3. So it's 3x plus this one is 1, this one is 3. 21 equals 10. Then let's take the inverse operation on both sides to find the x value. So I subtract 21 from both sides. 3x equals negative 11. Then divide both sides by 3. X equals negative 11 over 3. Let's look at the second one. The denominators are 16 and 4. What is the lowest common denominator for 16 and 4? We can find the lowest common denominator is 16. So I multiply both sides of the equation by 16. 16 times the brackets. Let's remove the brackets first. 16 times 5x over 16 minus 16 times 5 over 4 equals x over 4 times 16. Let's simplify the fractions. 16 divided by 16 is 1. It's 5x. 16 divided by 4, it's 4. Or you can say make this one 1, make this one 4. So 4 times 5 is 20. 16 divided by 4, 1, this is a 4. 4 times x, 4x. Although I have the variables on both sides, we know what we need to do already. We subtract 4x from both sides. Then no x on the right side anymore. 5x minus 4x. On the left side, let's combine the like terms first. We will have x minus 20 equals 0 left. Then I isolate negative 20 from x. I add 20 to both sides. So cancel these two. X equals 20. Let's look at the last question. 1/3 times brackets 5 minus 3t equals 5 over 6 brackets t minus 2. Let's cancel the denominators first. What is the lowest common denominator for 3 and 6 first? So the lowest common denominator is 6. I multiply both sides by 6. 6 times 1/3 is the same as 6 divided by 3. 2. Brackets 5 minus 3t. Close the brackets. 6 times 5 over 6. 6 divided by 6. 5 times 1. Anyway, it's 5. 5 times brackets t minus 2. In this case, I have the variables on both sides. I also have the brackets on both sides. I prefer to use the distributive property to remove the brackets first. 2 times 5, 10. Minus 2 times 3, 6t. 5 times 1t, 5t. Minus 5 times 2, that's 10. Right now, I have the variables on both sides. I will remove the t variable from the right side. So I subtract 5t from both sides. 5t minus 5t, they got canceled out. So 10, negative 6t minus 5t. Let's combine the like terms. Negative 6 minus 5, that's negative 11t, equals negative 10. This one is the same as negative 11t plus 10 if I rearrange the terms on the left side. So I want to isolate positive 10 from negative 11t. I subtract 10 from both sides. These two 10s got cancelled out. So it's negative 11t equals negative 20. Then divide both sides by negative 11. So the t value for the equation is 20 over 11.